So in the second part of this tutorial on the argumentation related projects, I'm going to focus on the argument games project. Remember the idea that we have in the case of an argument games project, similarly, we have the idea of a application that the student will build in which they can author argument frameworks. Okay, so they can author their own argument frameworks, design them, open, save, close them, and instead of the application being used by students or researchers to determine legal labelings, as I described in the last in part 1, instead of the application being used to evaluate the labelings of the framework, instead, in the argument games project, a student or researcher can reference the frameworks that can be authored and that can be designed and inputted and saved in the application. They can reference these frameworks and play argument games with the frameworks. What do I mean by that? Essentially, if you recall our earlier example in part 1, we had this framework, right? This argument framework. And we talked about evaluating labelings of this framework, the grounded and the preferred labeling. In the argument game approach, the idea is that one selects a given argument, let's say D, within the framework, and then one plays an argument game to establish whether or not D can be labelled in a preferred or a ground labelling. So the idea is, let's supposing, having constructed a framework, we then play a game in which the user of the application selects an argument, in this case D, and then wants to establish whether D is in, let's say, a preferred labeling or the grounded labeling. So let's take the question, is D in or winning in a preferred labeling? So you play a preferred game. And the idea is as follows. So the user selects D. So D appears here. So let's just write this here, D. Okay. Then the computer, so that's the first move in the game, right? The user selects D. Is D in a preferred labeling? Then automatically the computer will then look in the framework and see, is there any argument in the framework that attacks D? Yes, indeed, C. So then the computer will play the next move, which is C. Right? C attacks D. Okay. Then the user could then be told, well, look, you have a choice. Looking at the framework, you can move A or B. Right? Because both A and B attack C. So let's say the user moves A. Okay. Then the computer can reference the framework and note that B attacks A. So the computer moves B. So each stage, the user or the computer references the framework, and every move made, it looks at the framework and sees whether an argument attacks that move and makes that move. So the user moved D, the computer moved C, the user moved A, the computer moved B. Now in the preferred game, okay, only in the preferred game, in other words, only when trying to establish whether D is in a preferred labeling, only then can the user repeat an argument that they already moved in the line of moves thus far. So we've got this dispute, this line of moves, yeah? Now notice the user has already moved A. The computer then moves B. Now looking at the framework, A also can attack B back. And in the preferred game, even though A has already been moved by the user, so we've got U for the user and C for computer, the user can now move A again. Okay. Now at this point, the computer, basically the computer acts as the opponent, right? The computer is playing the opponent, trying to show that the user who is a proponent, trying to demonstrate that D is not in a preferred labeling. Right? So the user starts with D, the computer who's playing the opponent is saying, well, look, D may not be in a preferred labeling because there's an argument C that attacks D, and so on and so forth. So in this case, the user who is the proponent can repeat an argument A. Okay, we'll repeat this argument here. But the opponent, the computer, cannot repeat in a line. So although the computer has moved B before, now looking at the framework, B attacks A. But because the computer has already moved B in this line of arguments, at this point there is no legal move that the computer can make. Right? So having run out of moves, and with the last move moved by the user has successfully established that the argument D is in a preferred extension. Okay? So that gives you the idea, right? So that when you're establishing whether an argument is in a preferred extension of a given framework, the user and computer take alternative moves referencing the framework and moving attacking arguments where in any path from the root argument in the game to a leaf argument, the user, the proponent, establishing whether D is in preferred extension, can repeat an argument. The opponent, in this case the computer, cannot. Of course, it might be, the roles might be switched. It might be that the computer starts with D and then the opponent starts, the user, the human user moves C. So you can switch the roles, right? Also, you could have a possibility of a game where instead of the computer making moves, two students are looking at the framework and moving. Now, this is a very simple example, of course. Let me give you an example of the grounded game, which illustrates some other features of these argument games. Okay, so so now we are interested in whether, so we've got this, let's say we have this framework again authored. All right, we've got this framework that's in the argument framework window, and now let's say the computer, okay, or let's say we've got two human users, right, two students. So there's two. So one student wants to establish whether D. So one student, let's call that student, as I said, proponent, pro, wants to establish whether D is in the grounded labeling of this framework. So pro moves D. The other student looks at the framework, sees that there is an argument attacking. So we're going to call the other student opponent. Right? Now the proponent of D, who's trying to demonstrate that D is winning in the grounded labeling, looks at the framework and says, there's an argument A that attacks C. Okay. Then opponent looks at the framework and says, but B attacks A, so I can move B. Now, unlike in the preferred game, so remember in the preferred game, the proponent, the one who starts off trying to demonstrate membership of an argument in a preferred labeling, can repeat an argument that the proponent has already used in a dispute. This sequence of arguments is called a dispute. So proponent can repeat. However, in the grounded game, okay, proponent cannot repeat, but opponent can repeat. So proponent has moved A, opponent has moved B. Now looking at the framework, potentially proponent could move A back again, right? But in the grounded game, the proponent cannot repeat. So it's the flip of the preferred game. So that rule, that move is not allowed. Now, a feature that I didn't illustrate in the preferred game, I'm now going to illustrate in the grounded game, and this feature applies whether or not you play the preferred or the grounded game, which is the idea of backtracking. So at this point, proponent has no possible moves, right? However, both proponent and opponent, okay, can backtrack and try an alternative. So at this point, proponent cannot move A again. Right? This is not allowed. However, proponent can look further up and notice that when they moved A against C, there was an alternative. Looking at the framework, they could have also moved B against C, right? So proponent can backtrack and try an alternative. Again, opponent can look at the framework, notice that A attacks B. Okay? And at this point, again, proponent, because of the rule of the game, because they've already moved B in this dispute, right, in this line from root to leaf, because proponent has already moved it, they can't move B again, according to the rules of the grounded game. Okay? So, every way that basically proponent and opponent can exhaustively backtrack, right, and try alternative moves subject to these non-repetition rules. And at this point we notice now that proponent has tried both ways, A and B, but cannot now counter opponent's moves. There's nothing that they can move here because of the non-repetition rule, and there's no argument they can move here. So proponent has failed, opponent has succeeded, right, in demonstrating that D is not in the grounded extension because proponent has no response to any of opponent's moves. So D is not in the grounded labeling. And if you recall from part 1, we had remember that the grounded labeling was undecided, 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 undecided. Okay. Unlike the preferred labeling, there was a preferred labeling in which A was in, B out, C would happen to be out, and D in. So in the preferred game, as I showed earlier, proponent wins and successfully shows A is in preferred labeling. Now, this is just giving you an overview of the argument. There are some other subtleties and rules about how to play these games and how to evaluate who wins the game. But the basic idea is that the student builds an application in which they can enter, save, and open argument frameworks in one pane, and that the student can play the computer or perhaps play another student using these different kinds of argument games for the preferred and grounded labelings. And once you'll be able to animate these games and select arguments and move them in this adjacent pane in your application, and then the computer evaluates who is winning the game at any given stage, or who has successfully demonstrated that either the argument that proponent starts with is either in or not in the grounded or a preferred labeling.